Yes, Professor Menon, we can start this.
Okay. I'm very happy to welcome all of you to the Healing Earth 2.0 conference, organized by the Center for Climate Change and Sustainability, or 3CS, of Ashoka University. Healing Earth is the flagship conference of the center. It's held once a year in February. My name is Gautam Menon, and I direct the center along with Professor Ian Stewart, who you'll see tomorrow. Climate change is a problem that some have called a wicked problem. That term describes sort of social and societal problems that cannot be addressed in simple, unidimensional ways, but need communities, corporations, non-governmental organizations, academics of multiple stripes, and yes, people of all ages, in addition to governments, to come together to address them. If there's any progress we might be able to make at all, can only come at the intersection of these multiple approaches. Where Ashoka University and the Center for Climate Change and Sustainability can make a difference is precisely in this interdisciplinary space between different fields of research. As a liberal arts university, Ashoka University combines arts, humanities, and the sciences together. Indeed, 3CS is the most interdisciplinary center on the Ashoka campus, combining 27 faculty from 9 different departments, ranging from English to history to biology. This also allows for unusual collaboration between not just different sciences or different parts of the humanities, but also between the sciences and the humanities. Another area where Ashoka can make a difference is communication. We can take for granted now that climate change is happening, is induced largely by human activity, and is, to some extent, unfortunately, even irreversible, certainly over the short term. But given this, how do we communicate ways of action? How do we maintain hope, a commitment to issues of the environment, and pressure on governments to do what they must do? That's where understanding the nature of effective communication comes in. The sessions today and tomorrow examine 2 important areas that are central to 3CS. The first is economics as applied to climate change, and the second is the humanities as applied to understanding our ecological future of the world. So today is the first day of our 2-day program. We will have a session on the economics of climate change organized by my colleague, Professor Bhaskar Dutta. Tomorrow's session covers the Plant Humanities and is coordinated by Professor Shumana Roy. You can post your questions in the Q&A box and they will be answered by the speakers as they go along. I will now pass this on to Professor Dutta to take this over. Enjoy the session today, and I hope to see all of you tomorrow as well. Bhaskar.
Thank you. So I want to start by thanking all the speakers from different parts of the world. Some of you have had to wake up early. Some of you may have to stay back late, but thank you again. Our first speaker today is going to be Professor Jing. She's currently an associate professor of economics in the School of Economics and Management at Singh University in Beijing. She wears many hats. She's a deputy director of the Institute of Energy, Environment, Economy at again, the Singh University. She's also the deputy director of the Hang Lung Center for Real Estate at Tsinghua. Her research focuses on environmental economics, energy economics, and climate change policy modeling analysis. She has published widely in various journals, including Management Science, the Journal of Public Economics, Resource Economics, Energy Economics. So without further ado, I invite Jing to take over. Jing, you have about 30 minutes. I will signal about maybe around 25 minutes that you have 5 minutes left. Over to you. Thank you.
Thank you so much, Professor Dutta, for inviting me to attend Healing Earth workshop at Bhaskar University. It is my great honor to present some of our research here. Okay, so let me share my screen. So the title I want to talk about is reconciling climate change and local pollution. As we all know that climate change is probably the biggest challenge for our human beings. Here I just cite a graph from Climate Action Tracker. It projected the future climate trend till 2100. The graph shows that if we only keep our current existing low carbon policies, the global mean temperature would easily increase to 2.7 to 3.1 degree. If all countries fulfill their combined individual countries' climate action plans, like the NDC targets, then if we all fulfill these pledges and targets, then we can make the curve to decline gradually, but it's only a small amount. So maybe you can say that from 2.7 or 3.1 decline to 2.4. If we have optimistic with these net zero targets, very likely we might increase temperature by 2 degrees. But if you want to improve these policies to meet our 1.5 degree target that we raised in Paris agreements, which means we need more efforts. And you can see that the curves really requires a lot of efforts. So how does this mean, and how can we do that? Of course, it means that we need to much improve the NDC targets, and especially for developing countries, I think it is very important to optimize the pathways, to get sufficient financial support to cut the emissions, to boost their capacities. So there's something we might need to remember. What might be the priorities? So I want to highlight that the local pollution issues for developing countries. We know that net zero is always hard. This is hard for developed countries, but this is especially hard for developing countries like India and China. Since we still need time to develop, we need to spend a lot of efforts to alleviate poverty, to avoid middle income trap, to grow, and to make people happier. But the most important thing is that actually when we get richer, we will raise our energy demand. And then the other thing is, in most developing countries, fossil fuel is always the cheapest. So without any policies, without these directions, the energy supplied, energy used would naturally mostly relying on fossil fuel, like a coal. So this is actually happened in China. We look at the 2000 to 2010. Also, in the following slide, I will show you that. So with the income rise, with more use on the fossil fuels, then air pollution becomes a very severe problem. It becomes a more urgent problem. So China has spent a lot of efforts to control the local pollution, and it does achieve a lot of progress. So we still have a long way to go to mitigate the air pollution, but now we have a more aggressive and more difficult target is carbon neutrality. So for China, we need to reach carbon neutrality by 2060, and for India, I think is similarly by 2070. So these are the new targets. So these also raise the new challenges for developing countries. Last year in COP26, the Glasgow Pact, all countries agree that we need to accelerate efforts towards the phase down of unabated coal power and phase out of inefficient fossil fuel subsidies, while providing targeted support to the poorest and most vulnerable in line with national circumstances, and recognizing the need for support toward a just transition. So this pact emphasizes the need to mobilize global climate finance from all sources to reach the target, so that we can achieve the goals of the Paris agreements. This is especially highlighting the need to increase support for developing countries, at least $100 billion per year. I also cite a graph which actually has been made a couple of years ago by IEA. So this is assuming that in the new policy scenarios, that how China can peak carbon emissions. But the good thing about this is a projection by sectors. So we can see that basically the power is pretty difficult. We are very likely to pick the power sector, the carbon emissions from the power sector. The building sector is also seem to be flat between 2020 to 2040. The most progress made is actually in the industry sector. Most of these progresses is due to the technology changes, especially reducing combustion-related emissions. So that structurally that the industrial carbon emissions will decline. This includes the declining use of coal in iron and steel, the declining use of coal in cement production. So that is some good sign. But with the income rising, you can see a steady growth of the transport. So with the declining trend of the industry emissions and increasing trend of the emissions from the transport, so kind of like, and with the flat of the emissions from power and the building sector and other sectors, then there will barely, possibly we can pick carbon emissions by 2030. So at that time, this graph was made before China, before we committed 2060. So what can be done after that? And this is actually a lot of things to consider. What can be done? What is the optimal pathway? I think that also IEA and EASA made a projection about the other pollutants like SO2, PM2.5, NOx emissions. You can see that compared to the air, compared to the energy use, compared to the carbon emissions, these traditional main pollutants fall much quicker than the energy mix. So I wanted also to share some of the experience from China is, given the Chinese experience, what is the priority? Consider for instance, like we have less than 40 years to go for the carbon neutrality. I think for India, you have less than 50 years to go. So if every country has a 5-year plan, so in China, we have a 5-year plan. So all these different 5 years, what might be something that we should prioritize? For instance, in the 14th 5-year plan, in the 15th 5-year plan, these kind of things. What is most important thing? What should we do first? Okay, so I wanted to share some of the China's case. So this graph actually shows the PM2.5 annual concentrations in 2000 and then 2010. For 10 years, the pollution emission, these emission concentrations increased dramatically. So Chinese government has done a lot to try to bend this increasing rising trend of the pollution. So this right graph I cited from the recent Greenstone paper, the NVR paper. There are actually two lines here. The dotted line is a satellite estimation. The blue line is an emission monitored by the government. But still you can see a consistent story here. So from 1998 to 2012, the emissions steadily increased. But after that, we have done a lot of the measures, a lot of the policies. Most of these policies, as I interpreted, these are the short run, very strong government mandate policies. So it has a lot of measures here, like the, so we release the PM 2.5 monitoring data, enhanced the monitoring, linked with the government official promotion, a lot of these energy targets, pollution control firm shutting down. A lot of the policies going on. So you see that after 2012, that the emissions drop very quickly. So this is only take 5 to 6 years. You see that basically the emissions has been cut by half. Of course, that there are emission control mostly conducted by end-pipe technologies. So removing SO2, NOx, and eventually removing PM 2.5. When we think about the energy use, reducing energy, I have to say that it is more difficult because the economy are still growing. Energy intensity is declining, but the emissions and energy use sometimes are still increasing. So this also raises these kind of the challenges for a serious market-based instrument, which actually has already in place in China, but still may need more improvement in the future. For instance, that in China, we have resource tax reform, we have environment tax reform in 2018. And then starting from 2013, we start our pilot emission trading markets. And from last year, we have opened the national ETF markets. So these are all these policies rolling. Okay, so I wanted to share some of our previous studies that Tsinghua and Harvard University has been conducting to assess potential Chinese policies using a very unique integrated assessment framework, bridging economics modeling, emission inventory, atmospheric modeling, health estimation, and then finally to provide policy recommendations. So these are all my co-authors, partners, and then we also, all the methodology has been returned in this book, Clearing Skies Over China, which we introduce a systematic assessment framework to analyze potential future policies. So today I'm going to just shed some light on what we have done, and maybe this can also shed some light on in the future what kind of the policies we can adopt to reconcile, to prioritize our local pollution control, but also simultaneously considering our carbon emission reductions. So in this study, I basically working on the economics part modeling. So we use a computer general equilibrium model. So basically these kind of the numerical simulation tools. In our model, a little bit unique features, we econometrically estimate the consumption function. And then we have aggregate consumption by adding over consumption with different household types. We have top tier with 4 categories: food, consumer goods, services, residence. And then below each of these categories that we also have more detailed categories based on input-output table. But the utilities that these consumption functions that we estimate using the micro data set. The lower tier, we use the input-output table to decompose the top 4 categories into 27 household commodities. And then we estimate a bridge matrix to link the input-output table with our micro-level consumption data set. Finally, we adopt Professor Jorgensen's welfare framework, basically a Slasnik-Jorgensen model. We use these to calculate for the changes in social welfare with both efficiency measure and distributional equity criteria. And this graph gives a framework that indicate the analytical models that we use. So we have the CG model, and below that, we also have electricity power sector model, which has plant by plant database. In our different versions model, we also have a decomposed electric sector in this macro CG model. So we use this CG model to simulate different policies, and then we feed the results to our scientific group, which can help us to estimate for the emission inventories, and our colleagues who run the atmospheric geoscan model. And finally, that our colleagues from the public health school, they can help us to estimate for the physical effects and monetize the value of different policy benefits. Okay, so this is basically kind of the flow chart that shows that how we start from one model to the other part of the models. So I'm going to share some of the existing studies that we have already published. So this one is the one that we did 3 years ago on energy economics. So we use this framework, and then we simulate the national carbon emission trading. And then we also assume that maybe in the future, we can have a hybrid carbon tax and carbon emission trading. So we have different kind of the policies. We could have the ETS policy without auction. We could have a ETS market with auction. We could have a ETS hybrid with a carbon tax for non-ETS sectors. For the hybrid, we also have 2 policies, because in China, the ETS actually also has the carbon pricing on electricity use. So we also define 2 different versions of the hybrid. Hybrid 1 is still assume this embodied carbon calculation, but the hybrid 2 just remove that, just focusing on the fossil fuels. And this is our baseline trajectory of the GDP, energy use, and carbon emissions. And then we simulate for different policy scenarios. We found that if we start with the very small taxes and then gradually increase, the negative shocks on the economy will be actually in the beginning much smaller. But compared to the smaller negative shocks on economic performance, GDP, consumption, investment, the energy use reduction, carbon emissions, especially the local pollution reductions, are very significant. Of course, once you increase the tax rates, the impacts on the economy will get bigger, but still the magnitude on energy use, carbon emissions, they are still much bigger than these costs on economic side. We also try to look at the instance over different household groups. So we estimate for the equivalent variations in 2030 for different households. We look at the percentage change in money measure of welfare from the base case. And then we have 5 different income groups. We also look at different regions, whether these households are living in the urban area or rural area. So these are these dimensions that we look at. Besides the ETS policies and hybrid carbon policies, we also use another different version that we concentrate more on the policies within the electricity sector. So we build a more detailed electricity module inside of our CG model. That in this model that we have different technologies. We have the base load, coal-fired power plants, nuclear, hydro. We also including some of the future policy technologies like the coal with CCS, gas with CCS. And then we also have the renewables like wind and solar. Also in this setting that we wanted to look at, because still most of the carbon emissions coming from the power sector. So we wanted to look at what kind of the policies may induce these structure and technology structure shift within the electricity sector. So this is our projections of electricity generation in the base case. In the base case, still there are a lot of coal-fired power plants. We look at the different NDC targets. This was done also a few years ago with our World Bank colleagues. It shows that if we compare NDC 60% reduction target or 65% target, and mostly 65% target, for instance, like the reductions are almost 3 times of the target if we set at 60%. And then we also assume that if we have a national carbon tax, we tried a low tax and a high tax, basically corresponding to the lower bound of the NDC, the previous NDC targets, and 65 NDC targets, which shows how does that affect the different sectors. Okay, so this only shows that the cost. What are the costs? What are likely the sector impacts on different sectors? But also I wanted to share some of that our colleagues has done a lot on the emission inventories for future China, that we did a very detailed emission factor inventories modeling, and we had this emission feed into the global atmospheric geoscan model. So I'm going to talk a little bit about our previous work on the existing energy tax or existing taxes like resource taxes. So several years ago that we did a study. Suppose that China raised the tax rates on resource tax, and how does that affect the primary PM 2.5, SO2 emissions, and NOx emissions? So most of the benefits are, the mostly economic active regions in the northern part, eastern. Okay, so these emission reductions, we have tried for 2 scenarios, low carbon tax and high carbon tax. And then we look at geoscan model. This geoscan model is a nasty grade global model, but with a very more detailed simulation for the China region. It actually has interactions of 80 species, more than 120 chemical reactions. For China region, that these basically the grade is only 25 times 25 kilometers, but the global is more crude with 4 degree times 5 degree. The vertical resolution has 72 levels up to 80 kilometers, and then the model is run every 15 minutes time resolution. So because of it is very time consuming. So basically the simulation was done mostly for 4 seasons. And we picked January, April, July, October to represent for the 4 seasons. So the results that we find out actually for different policies are like a PM 2.5 ozones are sometimes show different patterns. So the good thing about these simulation is most of the results are validated by the satellite data and our ground stations results. So most of the simulations are basically to our colleagues have done a lot to validate the model to see how the model deviate from the observations, but most of these shows that the model actually fits quite well with the observations. So with this simulation that we simulated for the carbon tax with different tax rates, the low level and high level. And basically for PM 2.5, all 4 seasons, January, April, July, October, show substantial reductions in China. But the ozone is a little bit a different story, that the reductions mostly happening in the summer, but in the winter, in some regions, the ozone emission may increase. This is also consistent with one of these recent empirical paper by on the PNAS, suggesting that China reducing the PM 2.5, which actually contributed positively to the ozone concentrations. And finally, we have health estimation to look at the concentration, how the concentrations means to reduce health damages. So we have to combine these concentration map with the population exposure to compute the population exposure by matching China's population map. And then we can estimate for the physical units of the health effects. With the valuation functions, then we find the aggregate value of the effects, health effects that avoided with the policies. We look at the 4 different health endpoints. And then mostly we look at the premature mortality and the premature mobilities. And then we convert these into the renminbi units and then calculate as a percentage of GDP. So this is when we compare the resource tax, low carbon tax, high carbon tax. And for the resource tax, it shows that we can get 8.5 billion yuan benefits from the health benefits. The high carbon tax can receive much higher. Okay, finally, because of the time is really limited, so I just wanted to wrap it up here. So what are the future challenges? What are the future pathways for both China and India? I think it is very important to remember that we are still developing countries. We need to reconcile climate change. And possibly in the near term that our priority is local pollution control. So how can we control the air pollution, hopefully to make the emissions and concentration to decline faster, but also try to avoid the technology lock-in on fossil fuels, because there is a concern that with more NPAP technologies that investors may have incentives to build more, basically clean, more low emissions power plants, but this is only low emissions in terms of, SO2, NOx, PM, but not carbon. So that is one problem, but we need to try to avoid this. And then what is left is still to utilizing the emission trading markets to deepen the carbon pricing and try to use a better adoption of these market-based instruments to reduce abatement costs. I think academics are important, We need to model more policies ahead of practice. And business need to also try to enhance their learning by doing. I think this is also important to have a correct market signal to attract carbon finance from private sectors. So in recent 2 years that China has done a lot on the carbon finance, like the banks. So these are all very good experiences, but we haven't had time to summarize and to comment on that. Then will be the future work. I think this is also important to remember that there's a lot of potential implications about global climate finance and how does that support for developing countries. And finally, I think with all the regional emission markets set up, I think it is very, we're very positive that in the future, if developing countries can participate in the future linked global market, that will definitely improve the carbon abatement for performances in developing countries like China and India. Okay, so this is all my presentation here, and thank you so much.
Thank you, Jing, for a very stimulating talk and lots to think about. I see that there is, we don't have any Q&A. In any case, I think we should now move on to the next speaker. But again, Jing, thank you very much. Our next speaker is Professor E. Somanathan. He's better known as Som to most of us. He's professor in the Economics and Planning Unit of the Indian Statistical Institute. He has also been instrumental in setting up the Center for Research in Economics of Climate, Food, Energy, and Environment. He has published widely in many areas, including, of course, economics of environment and development. I want to hand over the floor to Som. Before I do that, Som, thank you very much. A special thank you for you. You have helped me in organizing the panel, and you've also got up at 5 o'clock this morning to address us. So over to you, Som.
Thank you very much. So I really enjoyed listening to Jing. Just give me a second. Right. I think I'm on full screen now, right? Okay. So I'll begin so we can stay on time. So I just want to talk a little bit about the economics of climate change from an Indian perspective. So I'll begin by just showing you these graphs, which I'm sure most people are familiar with. The problem is driven primarily by CO2 concentrations, although of course there are also other greenhouse gases which contribute considerable amounts. And that's resulted in this temperature increase that we see over roughly the last century or so. And as we can see, the global mean temperatures risen by about a degree or so compared to a century ago. And it's somewhat less over land and over India in particular. So let me go on to talk about economic impacts that we have seen in India so far. So I'll talk about crop impacts first. So the major crops have been impacted because India, being a tropical country, is already at, it's a region of the world in which we're already tend to be at the higher limits of what's optimal for growing these various crops. So for example, wheat, which is grown in India in winter, northern India in winter, wheat yields are estimated to be about 5% lower than they would have been if the temperature hadn't increased in the period of the 80s to 2009. So I think it's important to recognize that wheat yields have been growing. I mean, they grew by a factor of about 2.5 over this period, thanks to technical progress. But relative to what they would have been, they're lower. Right? So rice production is also a few percentage points lower than it would have been. That's a paper by Alfhammer, Ramanathan, and Vincent, which is now fairly old, and there have been more studies along these lines which show pretty much the same thing. In the non-agricultural sector, we find that heat stress has an effect on labor productivity, and that has resulted in a fall in manufacturing output, which is of the order of about 2% per degree rise in temperature. There have been other impacts. For example, there's been a threefold rise in extreme rain events over central India, and these are associated with damages from flooding. There's also been reduced total rainfall in the same period. That's for central India. And there have been increased heat waves and associated mortality. So these impacts are not negligible, but they're not huge either. They're about the order of 1 or 2% of GDP. And the important thing is this, that if these impacts are maintained at these levels of, small 1 or 2 percentage points of GDP, and GDP grows the way it has been doing in the past, although we've had a growth slowdown the last few years, but if GDP continues to grow at 7, 8, 9%, as it did in the early 2000s, then we can see very large increases in GDP, and there'll be a small decline in the level as a result of climate change. So, although that's regrettable, it's not disastrous, right? But that's if impacts continue to be at this level. But there's another issue which is quite important in India, which is that these impacts tend to fall more heavily on the poor, who are generally more vulnerable. Right? There are fewer safety nets and fewer resources to cope with negative shocks. So one long-run impact of this is that agricultural productivity losses tend to raise food prices because, of course, food supply is reduced. And the poor spend a greater share of their income on food than the rich. So as a result, losses to the poor in percentage terms are about 3 to 6 times greater than the first order impact on GDP, depending on how open the Indian economy is to trade or not. So if it's more important to trade, more open to trade, then the losses are significantly mitigated, essentially because India just imports more food and exports more manufactures and services. And also, of course, the faster the economy grows, then the smaller this effect, because the economy gets richer and this effect of the poor consuming a large share of their budget on food gets smaller. So far I've been talking primarily about impacts that we have already observed, but much greater impacts are yet to come, right? We know that because the temperature is going to continue to go up. So one of the issues which is of major concern to India is glacier and snowpack melt in the Himalayas, and that will reduce dry season water supply in the north. So under RCP 8.5, which is one of the scenarios of the IPCC, it's been estimated that 50 to 70% of glacier mass might be lost by 2050. So here's a graph from a report that came out recently. If you look at some of these also quite relevant to China, by the way. But if you look at panels I, M, and N in the second last row and the bottom row, so those are the ones which are relevant for India, the West Himalaya, the Central Himalaya, and the East Himalaya. You see, these are the predictions for going from 2000 to 2050 to 2100 of the amount of mass that's estimated to remain in these glaciers in these regions. And what you can see is that even by 2050, under RCP 8.5, which is the red one, you're getting mass loss in excess of 50%. And by the end of the century, it's much, much worse, right? And there's a considerable difference between the scenario that keeps you within a likely chance of achieving the 1.5 degree Celsius target as compared to the 8.5, which of course will take us to 3-4 degrees. Okay, so that's one major looming threat. Another one, which is very serious for India, is sea level rise. And so there's been some papers recently which essentially updated elevation information around the world. And these updated elevation estimates produced news that wasn't good. So this is Mumbai. And you can see that the city center essentially under these new elevation estimates is expected to be below the high tide line by 2050, right, for most of the city. So that's really an enormously scary consequence. 2050 is only 30 years away. And if these estimates are correct, and I want to say that all these projections are based on models and assumptions of various kinds, and so there could be errors in them, right? Things might actually not be so bad as estimated here. On the other hand, they could be worse. We don't really know until it actually works out. Anyway, but this is the best available estimate at the moment, and what it shows is really frightening, because we're seeing millions of people and the commercial hub, one of the major commercial hubs in India, most of it is going to go underwater. Well, that's not literally underwater perhaps, but underwater when tide is high. You can see this is the same source. And you can see that in Eastern India also there's going to be a huge problem. You can see that Kolkata is in the middle over there. It's in the edge of that red zone. So substantial parts of Kolkata also will be under sea level at high tide. And large parts of Odisha, West Bengal, and huge parts of Bangladesh. So one can imagine this is by 2050, which is really not that far away. So one can imagine the kinds of effects that this is going to have. And what is also a matter of really great concern is that, if this is correct, and then we're going to see a lot of impacts long before 2050, because there are going to be storm surges, which means that these places will get flooded much more often than they do now. Okay, so the other, the direct consequence of warming on India is also is likely to be very severe. All right, and again, it's because we are in a temperature range which is already at the high end of what people inhabit, and what people have historically inhabited in the last 6,000 years. Okay, So if you look at this map, what you see is that black areas have a mean annual temperature greater than 29 degrees Celsius today, right? And that's basically parts of the Sahara where, all the other deserts where nobody lives, essentially, or very few people. But you see that this band of mean annual temperature greater than 29 degrees essentially spreads to encompass a large swathe of the tropics in South America, Africa, Arabia, South Asia, and Southeast Asia, right? So this is again likely to mean that all of these issues that I raised, which have already been observed, are going to be magnified greatly. So it's going to, we might have quite severe cascading consequences. That's really the worry. So if these impacts remain confined to just, somewhat larger version of what we've already seen, then we can adapt them, right? The problem is that they might not, right? We could have, a series of disasters, and these can trigger migration in particular, large-scale migrations, which tend to go with political instability and conflict. And if those are severe and wide enough, then that can reduce investment and that can reduce economic growth. So the general assumption that we're going to continue growing the way we've been growing in the past, right? The investment climate is going to stay more or less the same, might not hold. Here's some work on the probability of conflict when there are adverse precipitation and temperature events. So this is a paper that looks at essentially a large number of studies which have been done looking at climatic changes, right? And what we can see is that there are a few studies which find essentially negative or small positive effects, which are not statistically distinguishable from no effect. But on the other hand, there are quite a large number of studies which do find an increased likelihood of conflict as a result of these negative climatic changes, which is basically temperature increases and precipitation declines. And we can see that it's quite possible that that we do have historical experience to suggest that these kinds of changes could trigger conflict. Okay, so it's also clear that emission reductions will not happen sufficiently fast to have a realistic chance of staying below a global mean temperature increase of 1.5 degrees, and also very likely not below 2 degrees. So we saw in Jing's talk, for example, that China, that there's a projection with regard to the power sector that there'll be a peak in emissions, but then a plateau for at least quite a while, right, in which emissions will not come down, right? And the kinds of emissions that the kind of emission declines that we do need to see in order to reach 1.5 degrees are extremely drastic, right? So this is what is projected. These are the kinds of emissions declines that you would have to see if you have a good chance of meeting the 1.5 degree target, right? So one looks at this graph and what's happening so far and how that has to change. It really seems very, very, very unlikely that it's going to happen. Okay, so that's kind of the bad news, it is kind of sort of frightening when one looks at some of these consequences that might come about, and it can seem sort of paralyzing. But I don't think we should stop there. And we have to ask the question, so what can be done to avoid these severe impacts? Because these severe impacts are coming, right? We know that things are going to get worse, considerably worse. Well, the thing is that India is still, not formally, technically a low-income country according to the World Bank definitions, but it's only, slightly above that level, right? With a per capita GDP of the order of about $2,000 per capita, which is about 1/6 of, maybe in PPP terms, third of China's. In nominal terms, 1/6 of China's. So clearly, the most important priority is rapid economic growth. It's the best protector, because it will reduce the number of very vulnerable people, and it will raise the resources available to cope with increasingly frequent and severe disasters that we know are going to come. Right, but of course, to get this rapid economic growth, and historically, I should say that India has had fairly rapid economic growth since the 1990s, and especially the 2000s, until about the last decade or so, when growth has slowed. But even with that slower growth, it's 4 or 5%. Which is not that bad, but it is, much slower than China's, and that's the reason that China has been growing about 4 or 5% faster than India every year for the last 3-4 decades, more or less. And the result of that is why China has a much higher income, and therefore it's in a much better position to cope with various impacts. In addition, of course, to not being as tropical, right, and having a much more temperate climate, especially in the north. Okay, so, but of course, to say that we should have faster economic growth, well, everybody's trying to achieve that anyway, and it's not easy. We are in a bad political equilibrium in which elected officials at central, state, and local levels don't have enough of an incentive. They do have some, but they don't have enough of an incentive to take growth-enhancing actions. And that's why we've had sort of middling growth experience rather than very high growth experience. And there may be ways out of this trap, but that's a subject for another day. So let me go on to show you essentially what the distribution over countries is of emissions. So on the horizontal axis here, we have GDP per capita adjusted for purchasing power parity. And on the vertical axis, we have the percent of global CO2 emissions by all countries up to that level of GDP, right? So it's sort of cumulative percent of emissions. And what you see, what stands out in this graph is that essentially low-income countries are basically negligible in terms of global emissions. They account for something like 1% or less of global emissions. That's those flat dots in the bottom left. Then you see a jump, and that's India, right? Because we're a large country, we account for about 7% of global emissions. And then you have some other lower middle income countries which are richer than India that gets you to somewhat higher percentage. If you take all lower income and lower middle income countries together, they account for less than 25% of global emissions. Right? So that you can see, read off the graph here. Then you get to higher income, which is basically upper middle income countries. And you can see that this thing jumps again. That's because China, of course, is a huge economy and has the largest CO2 emissions in the world, about a quarter or so, somewhat more than a quarter of world emissions. right? And then you get to the high-income countries, which together account for more than a third of global emissions. I just want to say that, I already made this graph with World Bank data, and there are a few missing countries in these data. So the percentages are not exactly accurate because of that, but they're roughly correct. And the US and China together account for close to 40% of global emissions. Okay, so the point to take away from this is that from the Indian perspective, 7% of global emissions isn't a lot, right? We could reduce emissions a great deal, but that's only going to address 7% of the problem, right? So 7% is not nothing. And it's also true that experience so far suggests that countries tend to strengthen their emission reduction policies in response to other countries doing so. And there are a number of reasons for that. It's partly because increasing the market for fossil-free technologies such as renewables and storage helps them move down the learning curve. That reduces costs and that makes them more attractive to everybody. Although this learning effect tends to happen partly within countries because of local supply chains being built and local financing being, de-risking of finance within country. But there's also, of course, global spillovers, right? And Chinese manufacturing, for example, has been a big contributor to these learning curves, increasing production for solar panels and wind turbines, which have brought their cost down. So that's one economic reason why emission reductions in one country seem to be triggering emission reductions in other countries. That seems to be the historical experience of the last few decades. It's also because other countries sort of observe, that other countries have reduced emissions considerably and that this hasn't hurt their economies noticeably, right? I think, for example, the European experience has been quite important in dispelling some of the fears that emission reduction policies would have negative effects, serious negative effects on the economy. Okay, so that's one. So there are positive externalities to other countries from emission reduction, and that's one reason that India should do it, even though we have, we don't account for a very large share of emissions. Of course, our major priority has to be to improve economic growth and development. Now, is it possible to do both? Well, we've had a spectacularly successful set of policies that have resulted in solar PV and wind power costs that are among the lowest in the world. These have been primarily driven by using auctions to procure renewable power that grew supply chains, found cheap finance, and drove down costs. So we have been extremely successful, at least at utility scale renewable technologies, much less so at decentralized distributed solar. Anyway, the effects of these policies, together with the global decline in costs driven by an expansion in manufacturing, primarily in China, has been that we have these fairly low renewable costs, right? So here's a graph which shows you on the left-hand side private costs, on the right-hand side social costs, which include externalities, both of renewables and of coal-fired power. So in India, most of our electricity, about 3/4 of our electricity comes from coal, right? So it's heavily emission intensive, and reducing that's going to be important. But also the power sector is the largest emitter of any sector in India. So if you look at, so what here again, these graphs are basically looking at coal capacity, arranged in order of increasing cost from left to right. Look at the panel on the right, which are the social costs. And what you see is that the red line is essentially just the cost of, it's just the cost of operating plants. And you can see that large fraction of coal capacity has costs which are higher than the cost of new renewables. And this is taking into account the externalities that renewables impose on the grid, right? Balancing costs and so on. And you can see, therefore, that we are already in a situation in which it's cheaper to build new renewables than to continue to operate many of our existing coal plants. Right? The difference, in the coal costs between the left and the right panels is primarily driven by air pollution, mortality effects of air pollution. Air pollution kills a lot of people, and that's the reason that the social costs are higher than the private costs in the case of coal. But the economic implication is that it is both growth enhancing and emission reducing to substitute good fraction of the coal power sector with renewables already, right? And that was these are for 2018 costs. In the same paper, we also did some projections for different electricity generation technologies, taking into account these learning curve effects that we're observing. And what we see is that by 2025, we are going to see costs of various renewable technologies with storage, right, which is the major concern with expanding renewable generation, is its lack of dispatchability, right? But we see that the costs of storage are also coming down. And so this projection suggests that by 2025, we are going to be roughly in the same cost range as building, it would be as cheap to build renewables with storage roughly as it would be to build new coal plants, right? So that suggests that actually it's economically sensible for India to pursue a rapid transition out of coal in the power sector. Okay, so what are the various actions or policies, roughly speaking? Well, we want to replace coal with renewables for power generation, not all at once, obviously, but we need to move in that direction, and we can afford to do so quite aggressively. So there is already a tax on coal in India. It's about 400 rupees a ton, which is equivalent to about $3.50 per ton of CO2, roughly speaking. So we should essentially raise that coal tax gradually in order to provide a signal to the market to shift the direction of its investments. We also need to upgrade our transport sector by decongesting roads, both highways as well as local roads. So we need to use congestion pricing, which hasn't been done so far. We need to upgrade railways, need to increase public transport. All of these will be both growth enhancing and emission reducing. Similarly, there are hardly any energy efficiency standards for buildings in India. Those need to go into effect. And we need to strengthen energy efficiency standards for appliances that we already have. And we need to reform electricity pricing in order to send the right signals for electricity conservation. That, of course, has to be done keeping in mind that the poor need to have access to electricity, all right? But the way that the subsidies are being delivered now are not at all efficient. So it's possible to essentially deliver subsidized electricity to the poor without distorting incentives too much, which at the moment isn't being done. So that's going to need some reform in the distribution companies. Do you want to ask your question now, Bhaskar?
Yeah, I just wanted to tell you that you have a couple of minutes left.
Okay, right. And then in the transport sector, we should electrify light vehicles. This electrification is actually happening in a market-driven way with 2- and 3-wheelers, especially 3-wheelers. Already about 30 to 40% of 3-wheeler production in India is electric, essentially because that's the cheapest option now. And we need to maintain our fuel taxes at a high level, which is always there's always some politics around that. So apart from trying to grow faster and doing what little emission reduction we can, what else can we do to protect ourselves, given that we face these fairly serious, very serious dangers ahead? So one of the things that has been receiving increasing attention in the policy domain here is geoengineering. And there are essentially 2 ways to do it. One is carbon dioxide removal. So you suck carbon dioxide out of the air, either chemically using non-fossil energy. There are technologies that exist, but they're expensive. Or biologically by increasing forest cover or growing algae in the oceans. Of course, there's limited land available to do that. And there are all kinds of problems with tampering with the oceans. And of course, there's the huge scale of the problem, which is the major factor, right? It's basically you want to run the entire industrial revolution and everything after in reverse, right? So you can imagine that's not going to be an easy thing to do. And the point is that it'll probably take centuries to sort of get back down to a safe level of CO2, even assuming that we're going to see rapid technological change if sequestration is incentivized with market incentives. So it's too slow, given the speed with which disasters can cascade. What we're talking about is decades, and this would take centuries. The other way is albedo enhancement, or what's called solar radiation management, which basically is increased reflectance so that less solar radiation enters. And if it's successful, it would reduce the temperature and can be done on a time scale of decades. But of course, it will do nothing about the CO2 concentration, which also acidifies the oceans and threatens marine ecosystems and food chains. So it's not a cure-all. One technology which has been proven in terms of its cooling effect is to inject millions of tons of sulfate aerosols every year into the upper atmosphere from aircraft. And it's been estimated that this would cost only of the order of tens of billions of dollars per year, which is less than 0.1% of world GDP. The problem is that it's very risky, right? So there are side effects. It might deplete the ozone layer and lead to unpredictable changes in climate, such as droughts. In particular, the Indian monsoon could be severely weakened, which is what some of the literature suggests. But we have to take into account the fact that we don't have any good choices here, right? So doing nothing is dangerous. Doing something is also dangerous. So I think it's really important that we do invest in creating the capacity to ramp up geoengineering quickly if we get to the point that the risk of not doing it becomes unacceptable. And I think that we are going to get there in the next few years. So we should probably start doing the research right now. So that's, I think, something very important, which is really not very much out there in the policy debate so far. And doing the research could also help find ways to avoid dangerous side effects such as ozone loss and monsoon weakening. There's also a strategic aspect to geoengineering, right? Countries are asymmetrically situated with respect to the risks from unabated global warming. As a first approximation, tropical poor countries like India are in greater danger in the near term than rich temperate countries. If India were to invest in geoengineering capacity, and thus signaling a willingness to undertake geoengineering and a capacity to do so, this could increase the incentive for temperate countries to reduce their emissions. Since if they don't do so, it will make it more likely that India will undertake geoengineering with all its attendant risks. This kind of argument is out there in the literature now, and I think it's something that has to be taken seriously. Although I think that the primary reason to do this is basically protective, right? You want to have the capacity to ramp up in case things get bad very quickly. Okay. And of course, if that does trigger a stronger climate agreement, that would be good for all countries, right? And of course, especially for poor tropical countries. Okay, I'll stop there. Thank you.
Thank you so very much. There are several questions for you. I'll read them out to you, and maybe you can take them one by one. So, Venkat Natimi, he asks, isn't RCP 8.5 too pessimistic? Same, and also, what is the scenario for current BAU? You want to take these first, Som, and then I'll the two other questions, I'll put them to you later.
Yes, yeah, I hope RCP 8.5 is too pessimistic, but we don't know that. And I think the point here is that all the policies that we undertake should take into account that we should not take unnecessary risks. It makes sense to pay some upfront costs now to avoid risks in the future, even though those risks may not materialize. Yeah, so I don't know what BAU is right now. When I was in the IPCC, the last round, not this one, that's about now about 10 years ago, we were very much tracking above RCP 8.5 at that point. You know, I don't know whether things have got significantly better. I don't think so.
There's another question. India plans to reduce its net zero emissions by 2070 and plans to do a carbon sink of 2.5 billion to 3 billion tons by 2030. How feasible do you think the target is? And would that be a possibility with the way with which India is going?
Yeah, so I think the 2070 target is feasible. I think that the carbon sink by 2030 is not, not unless there are very major changes in the way we manage land in terms of property rights. So yeah, that's, I think, the short. Well, basically the issue is this, that this is not just a matter of saying, okay, we have so much land, right? And in some official designation, this is wasteland, therefore we can plant a lot of trees on it. And those trees are actually going to grow. That's not the way it works, because in fact, there isn't any land which is really waste. Everybody's using all the land for something or the other, even though many of those uses are low value. Property rights are poorly defined, which is the major problem. And therefore, there isn't an incentive to actually grow more trees. In fact, if property rights were better defined, I think we'd get a big expansion in tree cover in India, because economically, that's what we're seeing. Lots of farmers in lots of places are actually growing tree crops because that's the most profitable thing to do. And that would expand if property rights were improved. But yeah, that's a big if. If property rights were improved, that would also lead to faster economic growth in general, because that's one of the constraints that we have, is that we have messed up land rights.
So another question, isn't rapid or faster economic growth going to further accelerate climate change? Won't coupling this with rising inequality and potentially non-inclusive growth lead to a large proportion of the Indian population being left to the elements?
Yeah, I mean, I do agree that of course, if you have rapid economic growth, there are going to be associated a tendency to increase energy consumption and therefore emissions, but and cement consumption. But as I suggested, there are ways to do this which actually will reduce emissions. Now, it's true that I left out the part that yes, you can, for example, grow in a way in which power sector emissions will decline. Some of the industrial emissions from coal will decline. transport sector emissions will decline. But even taking all that into account, there's still going to be unabated emissions in various sectors, which will grow with economic growth. So, but I think the net effect of the two sectors I talked about, the power sector and the transport sector, are really very major. And if one grows in the right way with those two sectors, I think the net effect would actually be an emissions decline, especially because of the power sector, which is really so huge and important. And about the inclusivity, yes, the thing is this, that part of the, it is true that our growth in the last 3 decades has been unequalizing, all right? That is, inequality has increased. More of the gains have gone to the top than the bottom. But it is still true that the bottom has gained. The bottom has gained considerably. So there has been growth all along the income distribution, all the way to the bottom. And if we were to grow faster, that effect would be larger. Now, of course, it's desirable that, we also have better redistributive and social security programs so that the growth isn't as unequalizing as it has been. But even if we don't, and we do have faster growth, it is going to benefit the vast majority of people.
Thank you, Som, and thank you for all the questions. We'll take a quick break of 2 or 3 minutes, and then we are running a bit, we're 5 minutes behind schedule, but hopefully we'll make it up later on. Thank you. Okay, so maybe we should move on to our third speaker, Suzi Kerr. So Suzi is currently a senior vice president and chief economist at the Environmental Defense Fund. She was until May 2019 a senior fellow and for several years, a founding director at Motu Research in New Zealand. She's also worked at the University of Maryland, Resources for the Future in the USA, and at the Joint Center for the Science and Policy of Global Change at MIT. Her research focuses on domestic and international climate change mitigation, policy with special emphasis on emissions pricing and natural climate solutions. She's the leader of the International Climate Action Teams Initiative. She's also a member of the advisory boards for Climate Econometrics Group at Oxford and the International Emissions Trading Association, Markets for Natural Climate Solutions. Suzi, the floor is yours.
Kia ora tātou, and thank you very much. Full screen mode. So, kia ora tātou. Lovely to be here today. I've really enjoyed the previous talks and learned a lot. I hope that this can add some ideas on some positive ways forward on top of what has already been suggested by Jing and by Som. So the key messages that I'd like you to take away are that if we can get effective transfers of resources and mitigation across countries, that can help us stabilise the climate faster. And as Som has made very clear, and Jing, that's going to be a really big challenge. But transfers for large-scale additional mitigation and enhanced mutual ambition towards faster climate reductions require a shared vision, trust, and true collaboration. It's not something that can just be done through a global carbon market. So we've been trying to develop a model that could actually achieve this, taking into account some of the realities of politics, international cooperation, etc. And we call this idea a climate action team, or a CAT. It's one mechanism to add to the set to mobilize resources that can accelerate the transition of developing and emerging economies to low emissions. And the key things in it are that it is large scale and that it is among small groups of countries who can develop a good trusting relationship. So in my talk, I'm going to first start by just laying out a few facts, some of which the others have already touched on, just to set the context of what it is that we're trying to achieve here. Then I'll talk about the specific ideas around how we can create these mechanisms for large-scale, high-quality transfers. And then finally, I'd like to end with some thoughts, really just to throw out on how India might be able to start engaging with international carbon markets. And I put it in quotes because I don't mean the sort of liquid financial markets that many people talk about, but much closer to a barter large-scale trade idea. So as you all know, first fact, Indian people are highly vulnerable to climate change. So this is some work from Carlton et al. In 2020 showing avoided mortality from, or rather potential mortality impacts from climate change. Again, this is an RCP 8.5 scenario, and I've pulled out specifically the results for Delhi, which suggest that there could be significantly higher mortality from heat and climate in general in Delhi in 2100. And I've just put on there one estimate for the total deaths from COVID so far, just for a little bit of comparison. This is on a similar scale. Second fact, we know that the world needs to transition to net zero emissions and needs to do it really fast. In Som's graph showing how much faster we have to do it with every year that we delay is pretty scary and compelling. Another fact which a lot of people, particularly in the US or in Europe, don't necessarily seem to appreciate is that most of this mitigation is going to have to happen in emerging and developing economies. So this is some emissions from energy-related CO2 emissions, which is a large fraction of global emissions. And essentially it's showing that more than 70% of reductions are going to happen outside of the OECD because 70% of the emissions are going to be outside of the OECD. And so we need to shift our focus really to making sure that we're able to do that effectively, as you all are focused on. Fact 4, reducing air pollution and greenhouse gases are related. Jing has shown this really clearly in the case of China and the really excellent modelling there. It does vary across countries because it depends on the sources of greenhouse gases and the sort of things that will be done to reduce those, but this relationship will hold within India as well. Quite a high fraction. In this picture, what you're seeing is the fraction of air pollution deaths that are coming from particular sectors or particular sources. And quite a few of those sectors and sources are the ones that would be targeted by mitigation policies. Fifth fact is that natural climate solutions, and possibly most relevantly in India, this is reforestation, could contribute nearly 1/3 of net reductions needed to get onto a 2-degree consistent pathway in 2030. Then these are modelling results. These are showing what is possible. They're not a prediction of what will actually happen. A lot of this is avoiding tropical deforestation, but it also includes a number of other pathways. So we know that to get climate stability at a temperature change that is something that humans can thrive at requires that the countries reach net zero emissions jointly. Climate doesn't get stable until after we do that, and faster is better. So for some countries, the pathway to get to net zero could be quite fast, appropriately would be quite fast. So what I'm sort of indicating here, these are not modelling results. These are not saying how fast they will get there, but you might expect places like New Zealand, where I'm from, the European Union, the US, to reduce their emissions fast and be at net zero by 2050, but more importantly, have reduced very quickly in the meantime. And after 2050, you might expect that they would be net negative, either in their own jurisdictions or because they're contributing to reductions in other countries. For countries that aren't as developed yet, like Chile or China, you might expect that that will take a little longer because of growth in population, growth in economies, and that they are just not as advanced yet. It's taking longer to implement effective policies. But where is India in this? You might expect that India is on a considerably slower path if this is India working entirely on its own, because you have other priorities. There are real challenges in implementing regulations in India, and India wasn't responsible for most of this problem. So if India is solving its own emissions on its own, you might expect that that will take a certain amount of time, even though, as some stresses, it is really important that India is on that path for its own sake. But what this sort of very general picture shows is that there could be real benefits. So these might be fair paths. They might be paths that are sort of pragmatic with the use of resources that are internal to these countries, but they're not efficient paths. There are a lot of opportunities for mitigation that could be implemented much faster in a country like China or Chile or maybe India if there was a lot more resource available to do that. And so what we're looking at here is how can we get more resource from countries like New Zealand or the US to countries like China or India or Chile. So there is modelling that shows that if we could have these sorts of transfers in an efficient way, we could potentially double global mitigation with no extra cost. But we can't do that with projects, which is the way so much of these international trades have been done so far through things like the Clean Development Mechanism. It's too high in transactions cost, too low in integrity, and it just doesn't scale. So the scale of transfer that we're looking at, if we did this efficiently, would be 2 to 4 billion tonnes of emissions credits annually through to 2025. And at $50 US a tonne, which is not now an unreasonable price to expect people to be paying, well below the social cost of carbon. But that's the price, for example, in the New Zealand emissions trading system now. That would involve $100 to $200 billion a year of payments. And that's not loans, that's payments. So this is a completely different scale than any of the mechanisms that we are currently considering. So for contrast, again, in the Clean Development Mechanism, cumulatively 4 billion units have been created and transferred. And most of those have been really low integrity, so they may not have led to any reductions in emissions at all. So we have two challenges. One is scale and one is integrity. So how do we create large-scale high-integrity units? What do they even look like? So first is that there needs to be no double counting. So the Article 6 rules, which have just been agreed in Glasgow, require that there are what's called corresponding adjustments, so that if somebody sells them, their NDC is adjusted, or their inventory is adjusted, and the person who buys them adjusts their inventory. So it makes sure that the emission reduction is not counted in more than one country. It requires strong monitoring, reporting, and verification of actual emissions. So this could be strong national inventories that are transparent, that people can really trust, that they're done consistently over time. It requires high ambition. So to make sure that these are additional, they're reductions that wouldn't have happened otherwise, either on the host side or on the partner side, you need to know that the countries actually have high ambition for their own contributions to mitigation. And we need to be making sure that these reductions are part of a long-term plan. We're not just doing short-term actions that reduce emissions this year, but that will be reversed in another year, or that are leading us down a path that cannot get us all the way to very low emissions. So we may not be able to get to very low emissions immediately, but there are things that we would have to start doing now in order to get right through to low emissions. And we should make sure we're doing those, or we're dooming ourselves to failure further down the track. Ideally, these credits would be created at an economy-wide or sector level, partly because that makes it much easier to get transparent monitoring, reporting, and verification, much easier to assess additionality. It also minimises problems of leakage, and it's more likely that you're heading through to something that is truly transformational because you're shifting the whole economy and not just sector by sector. And sectors, as we all know, are very much interconnected with each other. And it needs multi-year commitment. This is not something that just happens on a year-by-year basis. And I'll come to that a little. So how do we create and transfer high integrity units on a large scale? This is the problem that we've been tackling in the Climate Action Team project. So we start from an observation that mitigation is not a commodity. So mitigation is a reduction in emissions. You can't observe a reduction, you observe emissions, and you try to work out what would have happened otherwise, and the difference between those two is a reduction. So there's always an element of trust in the assessment of what would have happened otherwise, and that means that this will never truly be a commodity. It's dependent on institutional structures, it depends on estimates, etc. So we think that long-term relational contracts are a better model for transfers of mitigation effort, where people have deep knowledge about each other, they develop trust, and they're committed to each other in a long-term way. And a lot of private sector large transactions are done in this way. They're not done through commodity markets. So in some cases, these relationships between countries or states could be so strong that you could actually do a shared ETS or full ETS linking. For example, California and Quebec have emissions trading systems that essentially are combined. Or the European Union, they have institutions that create this long-term relationship. It's so strong that they can completely work together. But in general, that's not true. Existing ETS links don't support developing countries. They all are between developed countries, and therefore they can't generate the large trade gains from trade that we really need. We need to be able to engage countries like India or work with countries like India. So can we utilize existing trust relationships to support these trading relationships among very different countries that are not like each other and therefore don't have the depth of just sort of instinctive understanding? So what might this look like, taking an example in India? So suppose India was the host, or this was done maybe at a state level, and Karnataka could be a possible state. I don't know, I'm not Indian. I've actually never been to India, unfortunately. I'd love to come, but not yet. So suppose that they were considering something like this. They would get to choose who their partners are. Who do they like to work with? Who do they trust already? Who would it be beneficial for them to work with because they could learn from that country's technology? They have similar sectors. Maybe there are policies that the other country is doing that they could work together on, and also vice versa. So I've made up these countries. Obviously for India, India would need to work with some large countries. So I've left New Zealand off here because we're too small to make a big difference. But maybe they would choose Germany and the United States. And of course, Germany might be able to learn from India too. The learning is not a one-way thing here. So then the way that a climate team works, how does it calculate the credits that could get transferred? So we move to a national scale. So this is national level CO2 equivalent, or if you're doing it for Karnataka, you're talking about state level CO2. And you have some sort of projection of business as usual emissions. And that could come from a model that is transparent, it's open source, it's available for everybody to look at. So you agree that that's not an unreasonable projection of business as usual. But of course, the future is uncertain. We don't really know what business as usual is. But countries now, all countries, have nationally determined contributions which take them below business as usual. We can take those and use those maybe with increased ambition, but maybe based on that ambition, and generate an agreed crediting baseline. So what would be a reasonable track of emissions over time for that country to achieve on their own, or possibly with climate finance? And then anything that goes beyond that would be something that would be eligible for being rewarded, or would be appropriate to reward. And because the NDC is below business as usual, and because you're looking at a large scale and you have transparent modelling, you can be pretty confident that if that's a slightly ambitious NDC to start with, at least you're paying for reductions that are truly beyond business as usual. Because you could draw uncertainty bands around both of those, around that BAU line. And you want to be confident that you will be below those. And of course, there can be changes in economic growth. There can be changes in commodity prices, new technologies. The BAU has potentially quite wide uncertainty bands. Then the next step is to measure emissions. So instead of trying to look at this on a project by project basis, go to the national inventory. The national inventory might need to be improved, but it's based on some standard IPCC guidelines. They're done in a way that is consistent over time. It's something that countries need to produce anyway, not only for compliance, but in terms of being able to do their own planning for how they're moving forward. So you use the national inventory. It doesn't, any effort put into this is high value, so it's got low transactions costs. And then the difference between the crediting baseline and the measured emissions is the amount that would potentially be rewarded through the mechanism. So those are the additional reductions that could be transferred through ATMOs. So one of the key things about the climate action team model is that it can support any domestic policy. It does not require that within India, you are using project mechanisms or emissions trading system. It could be congestion pricing policies. It could be a faster rollout of the solar program. It could be any of the programs, any of the policies that Jing was talking about that have been used in China or that Som is talking about. Any of those policies can be done, and those policies are determined by the host country who needs to do the reductions. So they choose the policies and the actions that they think are going to be most effective in getting the reductions. So long as the national inventory shows that emissions are falling, then they're going to get a reward. It doesn't matter from the international perspective, doesn't matter how they got there. Of course, there are social safeguards and things that we need to consider as well. So a climate team, climate action team, has this set of partners. And I've slipped New Zealand in there again because we desperately need to buy some of these sorts of credits. So the first part of a climate action team is that once the countries have agreed to work together, so India has agreed to work with the US and Germany, US and Germany now have an incentive to direct their climate finance and their other climate-related aid efforts towards helping India actually get to their own nationally determined contribution, because there are no credits to sell unless India is in compliance with its own nationally determined contribution to start with. But then there's a contract element added onto here. So first thing, it's all very well to say that you're going to buy credits from somebody, but the price obviously really matters. And in the clean development mechanism, a lot of people put a lot of effort into creating projects. And by the time credits were actually being generated, the price had fallen close to zero and they felt very burdened. So the contract would involve a guaranteed minimum price that would protect India against prices that might go very low in the world, changes in the minds of Germany and United States about how much they're willing to pay. But at the same time, there's also a high price limit. So there's a ceiling price in the contract, which is an option to buy at a higher price. And that protects Germany and the United States against the possibility that we're getting close to 2030, there's a desperate need for these sort of high quality credits. And all sorts of countries are coming to India and saying, wow, you've got these really great credits to sell. We're willing to pay you $150 a ton. And so there's a protection for the buyer countries on the price that they are going to have to pay. It's no good having a price that agrees on, a contract that agrees that you'll buy some credits and on the price, you need to be confident that the funding will be there and the total amount of funding is available, because you're dealing with governments and governments change their minds. They have elections, things go differently, and you don't want to have invested a lot in transformational change and then not have the funding come through. So there are various ways of doing this, but the critical thing is that there is some sort of mechanism that ensures that the funding is going to be actually delivered. So one simple mechanism would be that the funding is literally put in advance into some sort of international impressed account. This could be a trust fund at the World Bank, if that's something that seems attractive. And that then the money cannot be taken back by the partner countries or released to the Indian government, except under the terms of the contract. And one of the challenges with this from the partner country point of view is that we're talking about enormous amounts of money. We've been modelling a potential contract in Chile, and you're talking about, for a tiny little country like Chile, you're talking about billions of dollars. Well, for New Zealand, billions of dollars is really significant in the government's budget, and they would find that very difficult to set aside in advance. But New Zealand has an emissions trading system, as does Europe, as do parts of the United States. And you could get the companies to have a deal with their own government where they put up the cash in front in return for getting the credits if and when they are created. And then these are results-based contracts, results-based payments. If the reductions occur, you see that they've occurred because of the national inventory, then the payments are made to the Indian government and the corresponding adjustment is done to make sure that this is all within the rules of Paris. But one final problem remains is that the US and Germany and New Zealand and India could all get together and make a crediting baseline that is weak, maybe not pay as much attention as they should to the quality of monitoring because the partners want to buy, the Indian government wants to sell, and so there is an incentive on all of us to make these agreements less high integrity than we really want them to be. So we need some sort of external observer mechanism to make sure that we are making the integrity of this agreement appropriately high. The agreement is not just a financial contract. The agreement would also involve governance and trust building. It involves mutual political support. As Som was saying, when some countries reduce, not only do you get learning by doing, but you also potentially have a political sort of reciprocity effect. Other countries feel more comfortable doing something when they're part of a club or a team of a wider group of people. Could involve technical support, and that can go both ways between the countries. It also needs to facilitate access to capital. So it might be that one of the things the partners bring to the deal is that they have greater access to capital and they can help to de-risk the capital that will be needed for transformation. And general mutual learning in terms of policy. How do you transform sectors? How do you manage grids with high levels of renewables and make the transition out of coal? Very similar challenges that are faced across countries. So we need to think large and small. So we need to cooperate on large scale reductions because that's the actual problem we're trying to solve, and large transfers. And that requires being brave. It's so much easier to sign a little agreement for a small amount of reductions or just a small part of a sector. It feels very low risk, and it is low risk in terms of that agreement, but it's very high risk in terms of the climate because you're not going to make much progress. So we need these large multi-year agreements, and we need to get to a point where we're confident enough to actually sign and implement them. But we need to work in small groups of countries. It's incredibly difficult to get large groups of anybody to cooperate well. We know that it's easier to cooperate and build trust in small teams. You can actually build relationships among actual people. You can truly understand each other's situations in a much deeper way. So small countries, small groups of countries can work better rather than trying to do it through the whole UN process. Of course, these need to be consistent with the UN process, but they can be much larger, much smaller groups within that, and they can be more ambitious in terms of integrity than the UN process is likely to deliver. UN process delivered the CDM in the past. I'm sure that they will do better this time, but there are still reasons why they won't do as well as we would probably like. So moving to India, and I'm way outside my knowledge zone here, so I'm just going to throw out some questions. I'm assuming that India is not ready to dive into this sort of thing immediately. But can we look for short-term actions which lead to some short-term gains? So there are real benefits to Indian people from the beginning, but that also set India on a longer-term path towards being able to receive large-scale support and do deep decarbonisation that benefits all Indians. So one first step, which some of my colleagues are working on with some wonderful groups in India, is to begin to explore what the long term might look like. So what does India need to be able to benefit from these large scale transfers? One of the things that is totally needed is modelling and understanding of the potential pathways towards low emissions, identifying what specific actions and investments will definitely be needed or are likely to be needed, when they will need to be taken, modelling what current ambition looks like and what the potential is for faster decarbonisation if there were support of different types, understanding of the co-benefits for health and the development implications of certain sorts of actions. India, to do a climate action team type agreement, would need strong inventory and transparent inventory, but also needs the ability to control emissions. There's no point in signing an agreement to transfer emission reductions if you have no idea how you're going to actually achieve those emission reductions. You can put a lot of work in and not actually reduce emissions very much, and then there's nothing to trade. So there's no gain to India, but there's also no benefit of being able to buy credits for the other countries. So developing the policies, working out what the policies are that are actually feasible in China, in India's situation, and governance of the agreement and of the actual implementation process, so that we're sure that all Indians will benefit and will give support to this approach. So moving on, just to highlight some work that is already being done, primarily by some Indian teams. They're called the IDEA modelling effort, and what they're building are highly granular, so very regionally and time-specific models, multi-year modelling of electric power decarbonisation for India. So this is just a picture model. I am not going to explain it to you. It's been done by a large team in 2 different institutions in India. And the sorts of things that these models are generating is some pathways for transition. So this is what a transition might look like in terms of the capacity of the sector. And if you look at that ore generation, look at your favourite, whichever one you find most interesting. And what you sort of see is a massive need for increase in solar. Right, starting from now, a less massive but still large increase in wind, and then a slow phasing out of thermal through time. And then within the model, there's a lot more granular detail of what exactly that could look like. And it needs to be passed through then into sort of what is actual pragmatic reductions. So next steps, in India, maybe it would make sense to start thinking about these sorts of large-scale agreements in just some sectors. So maybe just for electric power or just for reforestation, maybe just in some states where it's going to be possible to do this and where the states are interested and keen to make these sorts of changes. So it's an open question. What is most useful to do now? Because we're looking to develop our work in India. I know all of you are looking at where to direct your attention to. We're in this together. We all live on the same planet. And I really hope that working together, we might be able to solve some of these challenges. Thank you very much.
Thank you very much, Suzi. I see that in the Q&A, there's a question for you.
Okay. Yeah. So the question is, wouldn't it be easier for... Sorry.
Yeah, you can see it, right? Go ahead.
I can see it in front of me. So the question is, wouldn't it be easier for an international body to do a direct cash transfer? And, you know, we've been doing this for a long time, and we have things like the Green Climate Fund. And I think there are 2 really big problems there. One is that those bodies tend to be quite politicized. So they're not necessarily directing cash to the most efficient opportunities or the most effective programs. And also the cash may be transferred, but it doesn't mean that there are reductions that happen. And we have lots of experience of this happening. These projects sound fantastic in advance, but when you look back at what actually happened, emissions didn't fall. The other challenge is that they just don't have the scale of money. We're talking about hundreds of billions of dollars a year. The UN and World Bank don't have that sort of money, and they never will. So that's a real problem. It's also got, partners who have something to trade. If the Maldives presumably still have some mitigation action that they can do. If they need mitigation finance, then they do have something potentially to trade. I think, unless I'm misunderstanding that question.
Thank you. So I have to, thank you, Suzi, very much. And I have to, I'm afraid that our last speaker wrote to us about 45 minutes ago, saying that he's been caught up in an emergency and he won't be able to participate in the discussion today. So what we're going to do is we'll go to the panel discussion straight away. And maybe have a slightly longer discussion than was originally planned, but we'll still end maybe 10, 15 minutes early. We have a new member on the panel. By new, I mean someone who hasn't spoken already. That's Prachi Singh. So Prachi Singh is a High Meadows postdoctoral research fellow at the Environmental Defense Fund. She's well known in Ashoka because she was a visiting assistant professor at Ashoka University for a year. And she's also been an associate fellow at Brookings. She graduated from the Indian Statistical Institute in Delhi in 2020. And her research is on the health impacts of air pollution causing events like wildfire and crop burning. So to start off the discussion, I will request Prachi to speak to us for about 5 minutes, and then we'll open up the discussion to the panel. And you can also post your questions to the panel members, both on what the speakers have said so far, as well as any other questions you may have on the economics of climate change, and hopefully one of the members can answer your question. So Prachi, the floor is yours.
Thank you, Bhaskar. So I'm very pleased and honored to be a part of this panel. And let me begin by stating the obvious, that we know that we are living in a time when human activity has an impact on global environment. But more importantly, I feel that it threatens the achievements that we have already sort of had in terms of human health in the past few decades. So I'm going to sort of focus on human health and climate. I mean, what impacts does climate change have on human health? And that specifically involves rising temperatures, more heat stress days. And that essentially means that we are looking at higher mortality, particularly for elderly, but not exclusively. And it's not limited to elderly. It also includes neonatal mortality. We have a large section of our society who work in agriculture, which essentially means that they are out in the fields and they are more exposed to, such effects which are going to come in the future, and they're going to face higher neonatal mortality. But the effects don't just stop in terms of mortality, they actually spill over to other domains as well. We have evidence from the West that higher temperatures cause more frequent wildfires, and that has been linked to Alzheimer's. So we are also looking at mental health. So this essentially means that we are looking at a diverse set of health problems, which is only coupled by the fact that our health systems are not equipped enough to sort of address them. And it is matched by an equally disastrous health effect profile of air pollution. So we have already an overburdened health system, which is also ill-equipped, and we need to sort of somewhere address it. So when we were talking about sort of geoengineering sort of solutions, that's like a last mile solution, but let's talk about sort of climate resilient health systems as well, which means that we need to actively invest in our health system in preparation to climate change. And when we are like wrapping up in terms of policies that we can take up, we are sort of trying to address multiple problems here. We are trying to address climate change, which means rising temperature. We are trying to address better air quality. And we are also trying to address a bad sort of health system that we already have. So that means that we cannot have like a unisector approach here, but we need to address sort of all of them put together in form of a cohesive policy, which means that, of course, let's focus on phasing out coal, but also focus on more affordable fuels for majority of our population so that it remains affordable, cleaner fuels remain affordable for a longer duration so that there's a sustained adoption by them. And parallelly invest in our health system so that we are prepared for the worst. And lastly, I would like to add that somewhere I feel that in our electorate, we fail to sort of demand for better air quality, and climate change somewhere misses the mark in terms of our demand. And it's important that we somewhere demand health. I mean, it becomes an election issue eventually. I don't see it as an important election issue yet, but somewhere the responsibility lies on us as well to demand better policies in this respect, which sort of covers all the domains, not just air pollution and not just climate change, but also preparedness of our health system. So that's it. I'll probably stop here and take a pause and listen into my panelists and look forward to their comments.
Thank you, Prachi. So I had a question, one for Som and one for the panelists in general. Som, in your talk, you focused mainly on economic impacts. We talked about productivity, wheat productivity, rice productivity, manufacturing output, GDP. But as a sort of a layperson in the field of climate change, from what I read in newspapers, magazines, etc., I thought one of the main reasons for concern is health. So in your talk, you didn't really focus on health outcomes. And I wonder why.
Yeah, it was limited time, and so but I think that health is clearly it's one of the big concerns, and as Prachi pointed out, mortality due to heat stress is really going to be one of those things that is going to be very serious. I guess I sort of touched on that. I kind of implied it, I suppose, when I pointed out that we're going to have a large part of India which will have a mean annual temperature greater than 29 degrees Celsius, which is not a zone in which humans have ever lived in our entire history. So we are going to go outside the zone of experience, and that's probably going to have very bad effects. So that's I guess it's kind of implicit, but I totally agree with it. So that those are sort of kind of, I guess, more extreme. But even if you don't get mortality, you are going to get productivity losses, much lower temperatures, and that we've already seen in the data, right, since the late 90s. So the study I cited was basically using data from the late 90s to the middle 2010s, and that's we have already seen those. We've already seen those effects, and so they're only going to get worse. Yeah. So, but I don't want to minimize those aspects. I also, in my talk, I didn't really talk about lots of adaptation investments that are going to be needed. Kind of just sort of swept that all into the box of economic development, because a lot of these investments are some things that we would want to make for economic development purposes anyway. But some of them, I guess you could say, are sort of more specifically directed towards climate change. So we do need to strengthen our agricultural research and extension system, which we would want to do anyway. But in particular, because we know that the crops are going to face a lot, and livestock are going to face heat stress. And so we need to get more heat and drought resistant varieties, and that needs a lot of attention. So there's so many other investments that need to be made. We need to be much more sensible about our building codes and regulations. because we're going to face more extreme flooding events, for example. So, there are lots of things that are going to have to be done at the coasts as well. So, lots of adaptation investments are going to be needed. And, it's going to be very hard to make these investments unless we're a lot richer than we are. So it's really important that we, increase our growth rate, which has kind of slumped a little bit in the last few years.
Thank you. So I had a question for all the panelists together, which is that, again, it's more of an ethical issue. So if you take the different countries one by one, should emissions reduction be on the basis of per capita emissions across the different countries, or should it be taking the country as a whole? I guess the reason why I'm asking this is that often one reads about, well, China and India are the biggest polluters and they should do something. On the other hand, as Som pointed out, countries like the US, they're big polluters, and on a per capita basis, I'm sure the US comes out on top. So what do you think is the solution? And I see that Suzi has something to say.
Yeah, I think it's really important to separate out who does the mitigation, who does the reductions, from who bears the cost of doing those reductions. And in a perfect world, we would do the reductions first. Well, we would do them in the places that are most efficient to do the reductions, where we can get the most reductions as fast as possible for costs that we're actually willing to bear globally. And that tells you a different story about where the reductions are going to happen from any political story. So in an efficient world, there would be a lot of reductions in India and China that would happen quite fast. Also reductions in the United States and in New Zealand and in the EU, etc. And remember that everybody has to reduce ultimately. So this is not a question about who has to reduce ever. It's a question about who has to reduce fastest. So that's sort of where it should happen is where it's possible and where it's not outrageously expensive. And then there's a separate question, which is the one you raise, I think, which is the ethical question of who should pay for that. And I don't think it makes sense to think about this on a country basis. I come from a very, very small country, but which happens to have some of the best well-being in the world. And we recognize that we should take a larger per capita responsibility for these sorts of reductions. And New Zealand doesn't have a lot of historical responsibility, but that's just luck. But we should also take into account historical responsibility. I don't think this is a question we're ever going to answer, though. And one of the advantages of trying to make these agreements among smaller groups of countries is that you might be able to get 3 countries to agree on what is an acceptable level of effort and cost sharing within a small group when you can't get this sort of agreement on a very, very large scale.
Prachi, you want to come in on this?
Oh, yes. I just wanted to add that, of course, our global responsibility in terms of numbers can be less, but I think the argument goes beyond that because even without the numbers that we are seeing in terms of our own responsibility, we have enough reason to still sort of put in these efforts because of high air pollution numbers alone. So if we are going to sort of invest in, say, better air quality by, say, reduction in greenhouse gases, you already are facing an immediate local impact on health and even productivity. So without the reason in terms of, number of, in terms of contribution that India has, we have enough reason to go for it already.
Som, you.
Yeah, I guess, one idea that I wanted to throw up is something that Raghuram Rajan proposed a year or two ago, in which he suggested something that he calls a global carbon incentive. And the idea is essentially that countries which are above the average of world per capita emissions, which right now is about 5 tons per person per year of CO2 or equivalent, would essentially pay into a fund, and countries that are below the world per capita average of emissions, which includes India, China is, I think, a little above the average, would receive payments from this fund, right? And the idea is that the amount that you pay is in proportion to the amount by which your per capita emissions exceeds the global average, and the amount you receive if you're below the global average is in proportion to the amount by which your emissions are below the global average. So with that formula, it's sort of budget balanced. As much as is paid in gets paid out. And it's essentially a kind of refunded emission payment scheme, which you have, some countries have for various regulatory sectors, right, which are enforced by their governmental environmental protection agencies or boards. But this would operate at the global level. The attraction is that from the perspective of a country that's receiving payments, the incentives are aligned. So the country government has an incentive to prevent its per capita emissions from growing, because that will reduce payments next year if such an agreement is in force. And the problem, of course, arises from the other end, which is that given that the agreement is in force, then of course the incentives are aligned also for countries that are above the per capita average, because they will pay less into this fund next year if their per capita emissions have declined towards the average. But of course, the question arises as to why they should enter this agreement in the first place, right? So that's, of course, the major difficulty there. It sort of presupposes that you have high per capita emitting countries that are willing to make these transfers. Now, that's not, I think, an impossible barrier to cross, because, of course, the proportionality constant is going to determine what is the size of these payments. So if you keep that relatively small, so if you keep it at $1 per ton of CO2, then you're not talking large sums of money from the perspective of developed countries. But then correspondingly, it's not going to be that much of an incentive either. But still, I think you could arrive at something which is not very high, maybe $5 per ton of CO2, which is like about 10% of New Zealand's carbon price, for example, at the moment. If that was set aside for a scheme like this, then that amount of money is still a significant amount of money for a low-income country, right? For various sub-Saharan African countries, which are going to be putting in power infrastructure and so on, they would be incentivized to put in non-emitting fossil-free infrastructure, for example. So I think that that's kind of an interesting idea, and I just wondered how that would fit into what Suzi was talking about. Are these two things something that could be combined in some way? So rather than having this at the global level, you would have it in little small sets of countries. I'm not sure whether that would be something that makes a lot of sense. There's one other point I wanted to raise, which is that there is, when you're talking about this, you're talking about the distribution of costs for emission cutting at the global level. There is a tension between equity and efficiency, right? If you want efficiency, then you want to be forward oriented. You want to deliver you want to deliver incentives to reduce emissions going forward, right? In order to reduce the concentration, the stock in the atmosphere going forward. So the existing stock already exists. There's nothing you can do about the past. So in a sense, the past is irrelevant. What is relevant is the future. So that's from the point of view of efficiency in sort of delivering the right incentives. From an equity perspective, of course, however, the past matters, right? Some countries and people have gotten rich by essentially using the atmosphere as a sink and externalizing the costs of their development. Other countries didn't have the opportunity to do that. There might be, to some degree, a way of partially combining these two things. And that is if it's the case, and I'm pretty sure it's going to be the case, that at some point we are actually going to have to take carbon dioxide out of the air, right? So it's not only going to be net zero, it's going to be net negative that we're going to have to get to. And if that's the case, then it does make sense to have an agreement which says, well, when we get to that point and we start going net negative, maybe in 30 years, maybe in 40 years, whenever, then from that point on, countries are going to contribute to this pulling out the payments in proportion to their contribution to the stock, right? And then that aligns both equity and efficiency in the sense that it gives everybody an incentive to reduce their contribution to the stock, right? But it also means that historical responsibility gets factored in. Anyway, I should stop there. Let Suzi and others respond.
Suzi, you want to respond to this?
Yeah. So I agree. So something like that could be part of the way that you set up a smaller group agreement. And I would argue that it will be much easier to negotiate those sorts of agreements among a small group, because you're going to have to work out the proportionality. You have to agree to doing it in the first place. You might add in an element of historical responsibility into that. But getting that with 3 countries, especially 3 countries who India has chosen, is going to be a lot easier than trying to do it at an international scale. So I think it's totally possible. And what that mechanism on its own misses is that just because money goes into a fund and goes out again, yes, there is this sort of incentive in terms of getting future money, that if you lower your emissions, you can get more, but it's quite an attenuated incentive. So you might want to make that more strongly linked, which I think is sort of what we're trying to achieve. The other thing to be cautious of is that a country like New Zealand could be net below the global average quite soon, and that mechanism would imply that we would get paid. And that's completely inappropriate. So it's worth thinking through these sort of situations, that people's emissions, it's a great starter indicator, emissions per capita, but it's not always going to be a great indicator, and it's not a great indicator in all countries. Some quite poor countries have very high levels of emissions, for example, because they have a lot of tropical deforestation. So just the details of it, but I think it could be a really I love the way that it does actually create those broad incentives. It adds to those broad incentives.
Prachi, would you like to come in on this?
I mean, I agree. I was actually raising a point that even without these incentives, we should be focusing on decarbonization, or choosing like a better decarbonization policy, because we have enough health reasons to go for such a strategy. But I do agree that a planned strategy like this, which has built-in mechanisms for countries to participate, or to participate in a way that sort of incentivizes them even for the future, where they can sort of take out money when they have negative, net negative carbon scenarios, makes sense.
Moving on. So when I wrote to you, inviting you to participate in the panel, and asked you what would you like to speak on, you said you wanted to speak on a controversial topic, geoengineering. So would you elaborate on why you think it's controversial, and maybe Suzi and Prachi can say whether they think it's controversial, whether they think it's worth pursuing.
Well, can I wait for Suzi and Prachi to respond first?
Okay, sure.
You'll
So
probably
maybe
hear why
Suzi
it's
can go in
controversial.
first, and then Prachi.
So, yeah, geoengineering. I agree with everything that Som is saying. In an irrational world, that would all make sense. I think the concerns come from the fact that we don't live in a rational world. And so there is a real concern that the more geoengineering seems possible, the less we will try to actually reduce the emissions. And I do see this when I talk to high-tech people in the States, that they see this as a way out of the problem, that they see removals and geoengineering as, ways that potentially they don't have to change their actual behavior too fast. So I think that's one of the concerns. And the other concern, which Som points out, is the strategic concern that somebody might use it because it's locally beneficial, but they might cause huge damage to other places, like, damaging the Indian monsoon. And I don't have huge confidence that we have international institutions that are capable of managing that strategic risk. So I think we definitely should be doing more research, but we might want to be really careful about creating the possibility to actually implement this stuff. And I have no answer on how you balance those opportunities and risks.
Prachi, before Som jumps in.
Yeah, sure. It actually, reminds me of an academic sort of anecdote, which you guys might have heard of. There were two academicians, Paul Ehrlich and John Simon, if I remember correctly. And long time back, they betted that, Ehrlich actually suggested and believed that there's going to be a population sort of bomb and we're going to run out of resources. And he actually said that, we're going to bet on prices of like 5 metals. And because of the population bomb and less resources, he actually betted that the price is actually going to go up after 10 years. John Simon actually betted that after 10 years, choose any 5 metals that you believe in are going to sort of witness a rise in price. I'm going to bet that they're actually going to see a reduction in price. And what we did see after 10 years was that John Simon actually won. And the reason was innovation, because people actually moved away from those metals. So tungsten, for example. So geoengineering to me does sound like that innovation in this sort of, deal, which hopefully Som and other people who are sort of supporting it is going to win the bet.
Som, you've trained Prachi well, but maybe you should respond now.
Yeah, so the reason it's controversial, as Suzi said, is precisely this, that environmentalists have been very strongly against, environmentalists and climate activists have been very strongly opposed to geoengineering, because it's essentially, the history is that it was taken up by fossil fuel interests in the United States to say that, look, we don't really need to do much about this climate, cutting emissions, because we can just geoengineer our way out of the problem. And that's the reason that it's kind of become very controversial. And it's got controversial to the extent that lots of climate activists have very strongly denounced any attempts to even do geoengineering research. Now, that hasn't stopped geoengineering research from going ahead. In fact, it is going ahead. There's a huge literature on it, which has been exploding. But that literature is mostly climate modeling. So it's all about running these same climate models that you're running to see what's the future climate is going to look like under various scenarios. And here the scenarios include the injection of aerosols, usually sulfate aerosols, but not necessarily, into the stratosphere, the upper atmosphere, where they kind of spread out, and then they reflect sunlight, so they reduce incoming solar radiation. The reason that this modeling can be done fairly well is because you have some natural geoengineering going on. Every time there's a volcanic eruption, you get this injection of aerosols and you have a cooling effect. But what has been really strongly resisted in this whole debate is for people to actually do experiments, right? To send aircraft into the atmosphere, release aerosols, see what happens, take measurements. There was, I think, a proposed experiment which was supposed to happen in 2019 or something, if I remember right. And it was so controversial that it's been shelved. I think it's not yet been done. Now, that's the part where I kind of part ways with the environmental and climate movements. I think that we have got to the point where it's irresponsible not to do this research. It's really dangerous. And it's particularly dangerous from our perspective in India, right? And it's true that most of these climate activists who are denouncing geoengineering don't live in India. So, they don't really have the standing to make decisions on behalf of the rest of us. Now, of course, their ire is directed at mostly research being done in the developed countries, and particularly in the US. But I think it's really important that we move on to, more experimental research. The Department of Science and Technology in India has been funding geoengineering research for many years. And it is being done by climate scientists in India. I cited one of those papers by one of them in my slides. But I think that it needs to go beyond that. It needs to go to the point where we can do actual experiments and get a better sense of how one could do this more safely. And as I pointed out, there's one risk, by the way, which I did not mention. I mentioned ozone depletion, and I mentioned regional climatic changes, which can be adverse, like monsoon weakening and droughts. But there's another risk, which is that imagine that geoengineering is actually adopted at scale. So you get this layer of particles in the atmosphere. The problem is that if for some reason countries decide to stop it, then that protective shield will dissipate in a year or two. And in the meantime, if you've been increasing the CO2 concentration, then you will be out of equilibrium, right? The global temperature will be out of equilibrium and it will basically just shoot up when you remove this protective shield. And that rapid change is going to be even worse than what we are going to face if we don't do it to begin with. So that's another risk, and that's a risk which is essentially a political risk, and therefore, no amount of scientific research is going to be able to deal with that. So that risk is going to remain. But my point is that, look, there's a balance of risks, and the risk of not doing anything is getting worse. It's growing by the day, and the truth is it's greater for the tropical countries. So it really is the tropical countries that should be doing the research. And we haven't yet done it at the scale, I think, that we should be doing it. We are doing it. We're not doing it at the scale that we, I think, should be doing.
Okay, thank you. So there's a question from one of the participants. I'll read out the question and maybe anyone from the panel can address it. We have been witnessing COVID effect and yet to know full-fledged information on COVID long-term health risks. With this situation, can we get top priority of finance availability for climate change mitigation, comparing it to COVID research studies and public health? So I guess the question is, there is a fixed amount of money available. Should it be on COVID research and other public health issues or on climate change? Suzi?
Very, very briefly, and this is a question really to Som and the others, is there a fixed amount of money?
Well, to the extent that there is, whatever the money available is, I guess the question is, what should be the allocation? Should it be on COVID, other public health issues, or on climate change?
Well, I don't think that's really the right way to frame the question. If we look at R&D expenditures in India, for example, they're a very tiny fraction of the government budget. And so any change in R&D expenditures basically doesn't move the government budget at all, really. It's negligible. So I think we do need more R&D expenditures, and we do need them in several areas. Certainly public health, and COVID as one part of public health is one of them. But I don't think that means that we should stop doing research on new crop, drought tolerant, heat tolerant crop varieties, and that we should stop doing research on all kinds of other things, geoengineering or whatever. So I think that we do need more of all of those. We need a bigger, broader scientific establishment. So I guess that's my response. I don't think there's a real trade-off here.
Okay. Prachi, do you have anything to add?
I was going to say the same thing as Som. Primarily that people and even politicians tend to react to imminent threats. And that's why we see more investment in, say, COVID. But I agree that I think people still don't believe climate change to be an imminent threat. And hence there is less amount of sort of resources put into it, at least in case of India. So I would say the same thing as Som, that I would expect to see more resources being sourced towards this particular cause as well, which has equal, if not important, health sort of effects.
Okay, the last issue, and that's sort of very tentative question to each of the panel members. Suppose you had complete freedom, complete authority to choose some emission reduction policy, choose and implement. What would you do? So I'm saying, let's forget about political compulsions, political considerations. Suppose implementation is not a problem, or implementation is not the main concern, the main constraint.
So I'll go, if you like, at very high level. So I'm not going to talk about a policy within India because that's not.
I'm not talking about India, actually. I'm talking about the world at large.
Totally. So I would get the US State Department and EU Commission together with maybe India, if India is interested in being involved in something like that. And I would get a really strong agreement that would potentially transfer huge amounts of resources to India. I would get the private equity and the big pension funds in the room to link financial flows to these sorts of agreements, so that if India signs an agreement of some sort related to the sort of thing I've been talking about, then there would be enormous capital flows that would be de-risked by the money that is promised by these other big players. And then I would get together a super smart, or maybe first I'd get together a super smart group of Indian economists, or they would get themselves together more likely, to really, well, not just economists, but academics, to really plan out what a pathway can look like in India and what the right policies could be to actually implement that, so that these resources can actually be directed in useful ways.
But you know the common saying, if you get 10 economists together, you'll get 11 policy recommendations.
I don't think that's actually true.
I'm joking.
Really not if you get ones of Som's caliber. They might argue in the back room, but I think they're then going to be able to find. And it's not like there's one policy, right? We're trying to transform the whole economy. There's going to be a whole set of policies. And they're not, we've been too much in this, my policy is better than your policy state for so long. And now it's got to be a yes and. Yes, your policy makes sense. It mightn't be my favorite, but yeah, we should do that. and we should do these other things as well, and we should evaluate and improve as we go forward.
Okay, Som, and then Prachi will have the last word.
Yeah, I mean, I'm an economist, Bhaskar. What do you expect me to say? I'd say get the prices right. So, yeah, so we do need, I think, carbon pricing. Of course, it shouldn't be a shock. It should be gradually rising carbon price. But that's what we need worldwide. And then, of course, you need to use the revenues to protect the most vulnerable. And why protect? Why stop at protect? I mean, you can use the revenues to be redistributive and make transfers. I think that broadly speaking, if one had to say just one thing, what is the one most important thing? That's the one.
Okay, good. Prachi?
I mean, my sort of take would be assuming that we move away, which is like a tall goal or aim to sort of have, to move away from coal-based energy, and assuming that we have a cleaner grid. And then I would suggest that we should push more subsidies for electric vehicles. But what happens is that mostly these policies tend to benefit early adopters who actually don't need these subsidies as much, but should be targeted to people who are more sort of belong to that income class who cannot afford electric vehicles in the first place. So give subsidies for cleaner sort of vehicles to people who need it the most, and sort of move away from a subsidy model which sort of subsidizes these early adopters who don't necessarily need them in the first place.
Okay, thank you. Thank you very much, all of you, and thank you to the participants for attending this talk. I have benefited a lot from this discussion, and hopefully some of you have too. Thank you, and this concludes the program for today. Good night.
Thank you very much.
Thank you very much. Thank you very much.